Hello, greetings, and welcome to section 11.3, Areas of Regular Polygons. The diagram here shows a regular polygon inscribed in a circle. The center of the polygon and the radius of the polygon are the center and the radius of its circumscribed circle. So the distance from the center to any side of the polygon is called the apothem of the polygon. So we have that here with PQ. The apothem is the height to the base of an isosceles triangle and has two radii as legs. And an essential angle of a regular polygon is an angle formed by two radii. So we have that here, two radii, drawn to consecutive vertices. So we have M and N are consecutive vertices of the polygon. To find the measure of each central angle, divide 360 by the number of sides. So for right here, they're easy to see, 1, 2, 3, 4, 5, 6 sides. So 360 divided by 6 would give us 60. So MPN, that measure of that angle right there, of our central angle, would be 60 degrees. All right, so example 1, find angle measures in a regular polygon. So in the diagram, ABCDE is a regular polygon inscribed in circle F. Find each angle measure. So go ahead and press pause on the video and work these out, and then I will show you the answers. I said, please press pause. All right. So we have our diagram here. So in order to find AFB, which is a central angle, because you see you have two radii here that form it, so this is our central angle. So all we need to do is count the number of sides and divide 360 by the number of sides. So 360 divided by 5 gives us 72. All right, to find the measure of AFG right here is just half of our central angle, so we would just divide 72 by 2 to give us 36. Now, in order to find the measure of angle GAF, all we would need to do is subtract 72, which is the measure of our central angle, from 180 and divide that by 2. All right, so if we subtract 72 from 180, that would give us 108. Divided by 2 would give us 54. So GAF, right here, that angle measure would be 54. And for example 2, count them up, and we see we have 8 sides. 360 divided by 8 will tell us what our central angle measure is, 45 degrees. And then RCZ is just 1/2 of our central angle, and so we divide that by 2, just like we did up in our previous example, to give us 22.5 degrees. And then the same method here, 180 minus our central angle measure divided by 2 would give us 67.5. Moving on over. All right, so you can find the area of any regular n-gon by dividing it into congruent triangles. All right, so there's a couple ways we can look at this. Go ahead and put that there so you can copy it down. All right, so a couple ways we can look at it is 1/2 times S times A. So we see here, whatever our side length is would be our S value, and then our apothem would be our A value. Okay, so the base of the triangle is S, and the height of a triangle is A. Number of triangles would be our N value. All right. Also, if we had this, the commutative and associative properties of equality, in case you can't read that there. And then lastly, there are n congruent sides of length S, so perimeter P is n times S. And if you need to pause at any time, go ahead and do so. The area of a regular n-gon with side length S is 1/2 the product of the apothem, A, right here, and the perimeter P. So, the area is 1/2 times A times P, or 1/2 times A times N times S. Because, remember, in order to get P, it would just be the number of sides times S, the side length. So, either way you look at it. If you know the perimeter, then that's what you would use, or if you don't, then define the perimeter, just the number of sides times the side length. Alright, so go ahead and look at example 2 on your own, pause the video, and then I will show you how to work it out.